one leg of four-leg square stand used to place the sensitive instrument is found to be longer by 0.1 millimeter than the other three legs of length 1 meter each, causing the stand to wobble slightly. I think when you read the question, you should understand you have four legs. If you take this as the plate, square plate, four legs, there's a small difference in the one leg where it is longer 0.1 millimeter than the other, right? Each cylindrical leg has a cross-section area of 1 square centimeter, and they are made of material having Young's modulus 2 10 to the power minus 11. It should be 2. It should be 2 lamine. 2 10 to the power minus 11. It is not 2 10 to the minus 11. It is it must be actually 10 either. 2 10 to the power 11. It should be 2 10 to the power 11. There's a small correction to be done. 2 10 to the power 11. Please correct it. There's a small correction to be done. There's a typing error. Please correct it first. 2 10 to the power 11. It is positive. 11. The stand top consists of a uniform square board of side 1 meter long. The four legs are fixed at the corners of the board as shown in the figure. Assume that the stand has a negligible mass. I want you to understand this particular question first. So you have a square board, and there are four legs. Let's say A, B, C, and D. The one is 1 meter long. There is a small difference in here, which is I marked the star. 1 plus 0.1 millimeter is there. 0.1 meter plus 0.1 millimeter long. 1 plus 1 meter plus, you can't see that. The one leg 1 meter plus 0.1 millimeter long. There's a small difference. So if you have a difference like that, what will happen? Start to wobble, because all the four legs are not in the same size. They are wobbling. Each one has a cross section. Each leg has a cross section of 1 square centimeter. Let's say capital A, 1 square centimeter. The Young's modulus of the material is given 2 10 to the power 11 Newton per meter square. Right. Can you understand, before proceeding to the answers, can you understand the practical situation? I always want you to understand practical situation, then only you can try for the next question. Practically understand that. මේසයක් තියෙනවා, මේසේ legs හතරක් තියෙනවා, එක leg එකක් විතරක් පොඩ්ඩක් length එක වැඩි යාගේ. කොච්චර length එකක්ද වැඩි යාගේ? 0.1 mm වැඩි අනිත් ඒ වලට relatively. ඒක නිසා මෙයා wobbling වෙනවා, wobble වෙනවා, slightly wobbling වෙනවා because there's a small difference. Right, okay. With that idea, we can get into the question. Keeping a weight at a suitable location on the stand top can be made horizontal by compressing the long leg along so that the stand no longer wobbles. We have to remove this wobbling part, wobbling situations. They ask you question: where do you keep the necessary weight on the stand? Find the weight thus required. What is the point? If you want to remove this wobbling part, wobbling section, I should place a weight so that that particular weight should compress that 0.1 millimeter. If so, all those four legs are now in the equal length, so there is no wobbling. Anything to ask? Can you understand that? So we have to find a suitable location. Can you understand that can be happen? When you place a certain weight, you have to decide what is the weight you should select. When you select it, you can press 0.1 millimeter. If so, all the four legs are now equal in length, though there is no oblique. Can you understand that? Right, fine. If so, where I should place my weight? That is the question. I should, if I say I should place my weight on top of this leg, then I know that only that leg would be compressed. Only that leg would be compressed. So other legs cannot be compressed. Other legs need not to be compressed. If I want to place, if I want to compress 0.1 millimeter, I should place a weight, a certain weight on top of the D, top of the D. So shall we write where do you keep the necessary weight on the stand? Shall we write the answer properly? Just write under that, right on the right on top of the longer leg, right on top of the longer leg. With the numbers, please write the answers. Right top on the longer leg. We have to place that. Then it is only compressed. That leg would only compress. Find the weight thus required. So I need to compress 0.1 millimeter. I need to compress 0.1 millimeter. Let's say the weight we should place here, weight required equal capital F. Let's say F that let's say capital W. Here we can apply the Hooke's law. F over A equal E over L. F is W, AY E over L. W equal weight required equal W with that number, question number. A equal 1 10 to the power minus 4. Young's modulus 2 10 to the power 11. Extension is 1.1 millimeter 10 to the power minus 3 divided by the length. It is 1 plus 0.0001. 0.0001. So do I need to write 1.0001? No, I don't want it to write like that. So I just skip and say that it is 1. So the required weight is what? W equal 1 10 to the power minus 4, 2 10 to the power 11. 0.1 into 10 to the power minus 3 means minus 4. So minus 4, 11, that means 2000 Newton. So I should select a weight and place on top of D location 2000 Newton. That is what I should do. Weight required equal W, and come to this point because I don't have enough room, enough location to write these answers. I should erase the board once you complete that part. If you have anything, please let me know. ළමයි මෙදසල viral flu එකක් යනවා පොඩ්ඩක් පරිස්සම් වෙන්න. දැන් අපේ ගෙදර ගත්තොත් මගේ පුතාට හැදුනා, වයිෆ්ට හැදුනා, දුවට හැදුනා, මට අද හැදිලා තියෙනවා. ඒක නිසා පරිස්සම් වෙන්න ඔයාලා. මේ වෛරස් එකක් ඒක හැදුනම ටිකක් අපහසුයි ඇත්තටම. මම දන්න හුඟක් කට්ටියට හැදිලා තියෙනවා. ඒක නිසා මොකක්ද කියලා දන්නේ නැහැ. නමුත් ඒක රිකවර් වෙනවා. නමුත් ඒක අපහසුයි. ඒක නිසා පොඩ්ඩක් පරිස්සම් වෙන්න හැදුනහම හැදෙන්න ඉස්සෙල්ලා පරිස්සම් වෙන්න. Right. Right. Okay. Number B. I will come to number B. Instead of the weight used in one, another weight of 4000 Newton is placed on the stand to compress all four legs. All four legs. It must be 4 legs. All 4 legs so that the stand top become horizontal and the stand does not wobble. Find the decrease in length of each leg. So now the question is bit different. Instead of 2000 Newton, they would place 4000 Newton. If you place 4000 Newton on top of D, what would happen? What would happen? You ask me why. The one is asking me why it become 1 plus 0.1, because the length of this original length of that is how much? 1 plus that 1 millimeter. So I should write the capital L, which is the original length. Kenul Terunada. Is it clear for you? What is the length of this? What is the length of this leg? It's not 1. It is not 1. The length of this leg is not 1. All the other 3 is 1, but here it is not 1. 1 plus 0.001 meter. Clear, ne? Hurry, okay. So my question is there. If you place, so now we realize we have to place 2000 Newton in order to compress 0.1 millimeter. If you place 4000 instead of 2000, what happened? Yes, Ramishka is giving the answer. Yes, it will compress more. It will compress more than it required. So what will happen then? Again start to wobble. Again start to wobble. Now all 3 are equal in 1 meter, but the other one is these even less than 1 meter. So start to wobble. So we have to place 4000 Newton in a suitable location. How to decide that? Okay, I will explain that. So look at here. Let's say this is the plan view of this table. I will mark location A, location B, location C, location D. Here, the first thing I should do is what? The first thing I should do is what? I should compress 0.1 millimeter. Then I know that all those 4 legs are in equal value. What is the value? What is the weight I should select for that? What is the weight I should select for that? 2000 Newton, exactly 2000 Newton. Let's say I place 2000 Newton. It is D, ne? According to my diagram, it is D. It is B. 2000 Newton. For the time being, let's assume I place 2000 Newton here. So what is the balance amount? What is the balance amount? Now all the 4 legs are in equal values, equal length. Am I correct? What is the balance amount? The balance is 2000 Newton, right? I will place each on 1 legs. 500 Newton, 500 Newton plus 500 Newton. Are you clear with that? 500 Newton. Are you clear with this? Fine. If you want to provide equal effect for all those 4 legs, where I should place that 2000 Newton weight? Where I should place that 2000 Newton to provide all that effect? Equal values, 500, 500, 500, 500, altogether 2000. Yes, exactly. The center of gravity, actually, it is not a center of gravity, it is the intersection point of this. It is at 2000 Newton. I should place 2000 Newton, then equally 500, 500, 500, 500, apply. Is it clear? The question is not yet completed, but I want you to understand 500, 500, 500, 500. Instead of placing 500 in each legs, on top of each legs, I just put 2000 Newton. So equally it is distributed 500, 500, 500. Are you clear with that? Right, fine. I remove it now. I know, but I know it is equally distributed. 500 cancel, 500 cancel. Now you have 2000 Newton, 2000 Newton. Where I should place 4000 Newton based on the knowledge we have under the center of gravity? Let's say this is the intersection point is E, where I should place the exact center of D and E. Yes, exactly. It is the center of this. It is the center of this. I should place 4000 Newton at location this, at location here, right? Let us say location O. Location O. Exactly, I should place 4000 Newton at this point, which is the bisection of this, equal bisection of that DE, equally divided that value, equally divided the length. So it is O. So I remove this 2000 now, remove this 2000. If I place 4000 Newton, which is the midpoint of DE, I could able to compress all four legs equally and there's no oblique part. Are you clear with that? So look at that, how nice the question is. You should understand it clearly. Right. Right. Just write under this. Therefore, you just mark. I think you are clear with that what they want the answer. Just write under this. Therefore, the weight of 4000 Newton. Therefore, the weight of 4000 Newton should be placed or should be kept at the center of ED or DE, at the center of DE, at the center of DE. Center of DE. We will write something more for the answer. For the leg A, B, and C, 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 £500 each applied, 500 Newton each applied, 500 Newton each applied. For the leg D, the applied force is 2500 Newton. 2500 Newton. 2500 Newton. 2500 Newton. In part B, part A, they ask one question: find the decrease in length of each leg. Find the decrease in length of each leg. Let's say leg A or B or C. You can take whatever the leg you like out of these three. Let's find it. F over A, Y, E over L. They want us to find E, F, L, A, Y. Right? So E equal, F equal 500, length is 1 meter, cross section 1, 10 to the power -4. The Young's modulus also given 2, 10 to the power 11. So E equal how much here? E equal 500 multiplied by 500 divided by 2, 10 to the power 7. 500 divided by, or we can say 5 by 2, 10 to the power minus 5. It is 2.5, 2.5, 10 to the power minus 5 meter. Here 0.025 millimeter. 0.025 millimeter is the answer. I suppose it is the answer, right? 0.025 millimeter. So extension of the compression of longer leg D, this is for the A, B, O, C. For the leg D, it should be how much? 1.1 millimeter plus 0.025 millimeter, which is equal to 0.125 millimeter. 0.125 millimeter. millimeter. Decrease in length. Decrease in length for the leg D, which is selected as a longer leg. Decrease in length for the leg D equal that value. This is for A, B, and C. It is the 0.025 millimeter. No need to do the calculation because we know that it's only 0.1 millimeter extra we have to compress. So it is simply we can get the answer. Find the reaction on each leg by the flow. It is not even difficult. It is something like placing 500 Newton, 500 Newton, 500 Newton. This is 2500. So the same forces would be developed as a reaction force. The leg does not have any weight. Like you place 500 Newton, 500 Newton, 500 Newton. So the reaction force is equal in 500, but here the reaction is 2500. Are you clear with that? Shall we write there? Shall we write there? The reaction force on leg A, comma B, comma C is 500 Newton, respectively 500 Newton respectively, and for D it is 2500, and for D it is 2500 Newton, and for D it is 2500 Newton. (2,500 Newton). Right. So I will come to question number 31 now. Question number 31. Look at question number 31 in your tutorial. I think this question is clear, ne? You have anything to ask regarding this? Other page? No. There is right. No. What is that question? See, where do you keep the weight? So we have actually I answered the question, ne? I answered the question, ne? Yes. we have already given the answer for that question. No need to do it again because we have already highlighted it should be kept in between E and D. I think I answered the question. Right. Are you clear with that? Okay, fine. Right, okay. Shall we start question number 31? Look at question number 31. ඔයාලා බලාපොරොත්තු වෙන්න එපා මේ questions මෙච්චර ප්‍රමාණයක් නම් කරයි කියලා. ඒක නිසා මහන්සි වෙලා කරගන්න. මේවා ඔයාලට ගොඩක් important වෙනවා. බලන්න මේ questions කොච්චර පහසුද කියලා. අමාරු නෑ ඇත්තටම. If you try yourself, definitely you can score the exam. The elasticity is very simple. Only the difficult thing is if you try at the last moment, you don't have enough time, to do the questions, then only you feel difficult. So please take the advantage of the previous class. So I know most of the students are doing well, so please continue it. Question number 31. Question number 31. Question number 31 in your tutorial. Figure 1 shows the stress strain graph, strain curve for a uniform steel rod. Identify the point A, B, and C underground storage is okay. They ask you to identify these locations. Question number 31. You can't see that. A, B, and this is C. Identify the location A, B, and C. What is A? It is proportional limit. B is elastic limit. C is the breaking point. I will repeat it again. A is proportional limit. B is elastic limit. C is breaking point. Okay. An underground storage is of length 150 centimeter. Actually, it is not 150 centimeter. It is 150 meter. The graph is indicate the proper values. 150 meter. It's not centimeter. It's mistake. 150 meter, which is 6 meter, is to be constructed at a depth of 20 meter. Underground storage, right? Underground storage, the volume is given 150 into 6 into 20 from the ground level. Figure 2 shows the side view and the figure 3 shows the front view of the storage, right? Front view, the side view is provided. The weight of the soil existing above the roof of the storage is to be supported entirely by 30 into 30 square steel columns. So you have a huge underground storage. It is supported by square steel columns. They haven't highlighted how many. The solid has a uniform density of 3 10 to the power 3. The soil, it is not solid, it is soil. It is soil, Lamai. Soil, right? Can you make this correction? I added this question as a new question. There's a small mistake. The soil has a uniform density of 3 10 to the power 3 kg. There is storage. According to the question, this is 20 meter, and this is 6 meter, and the length is given as 150 meter. 150 meter. 150 meter. The important thing is it is fully filled with the soil. It is supported by few rods like this, which have a square area. Of this. It is given as 30 centimeter into 30 centimeter. Area is given as that. We don't know how many. The inside this we have a soil. The soil density also given. Soil density rho 3 10 to the power 3 kg per cubic meter. Calculate the total weight of the soil that the column must support. So how to find the total weight? We have to find the total volume. It is not a big question, right? If you consider these are the big question, or it's not that. Don't think about the figures. They are not that much difficult. How to find the total mass of this, total weight of that, total weight of the soil that the column must support. The total weight we can calculate for the part A, part 1, total weight equal W equal volume into density into G, since they asked you to find the weight. W, the volume 26 into 150 rho 3 10 to the power 3 into 10. W, you would get an answer for the W. W equal 5.4 10 to the power 8 Newton. 5.4 10 to the power 8 Newton. This is the soil weight. Total soil weight. We will write like this: soil weight equal W. Total soil weight equal W, which is 5.4 10 to the power 8 Newton. Anything to ask, any one of you? Inside this, we have a soil. Even in the figure number 3 and figure number 2, it is given. Right. What is the number of columns need to keep the compressive stress on each column at 2 10 to the power 8? Assume that the weight of the soil equally distributed along the columns. Neglect the mass of the roofing material. What is the number of columns need to keep the compressive stress on each column at 2 10 to the power 8? Let's say the number of columns required as n. Number of columns. Number of columns as n. Number of columns as n. Actually, what need to be done, these particular columns, let's say we have n number of columns, those columns must withstand this particular weight, right? This must be they provide an answer. This the compressive stress on each column must be 2 10 to the power 8. 2 10 to the power 8. The compressive stress 2 10 to the power 8 Newton per meter square. It has to be there, right? Total weight is supported by these columns. N number of columns. We have n number of columns. The total entire weight is supported by that. They ask you to take, not to take any roofing material weight. Only the soil weight we have to consider. We have taken n number of columns are there. Then total number of columns is n. If so, we can say the stress equal the force divided by the area. But how to find the area? Area we can take n into simple A. What is simple A? It is equal to the area of a square column, n into A. Force is how much? 5.4 10 to the power 8. That has to be tolerated by these columns until it is 2 10 to the power 8. 2 10 to the power 8. The force is 5.4 10 to the power 8 divided by n into A. 3 30 30 10 to the power minus 4. So when you simplify that, n equal 5.4 10 to the power 8 10 to the power 8 cancel. 5.4 10 to the power 4 here. 30 into 30 into 2. We get n as 30. We get n as 30. 30 columns. N number of columns, 30 columns. If I ask you simple question, if you provide more than 30 columns, what kind of a stress you would get? Would it more than that value or less than that value? If you provide more columns, more than 30, would you get the stress more than that value or less than that value? I think the answer is given, less, actually less. The stress is not that much big. If you provide less than 30, what kind of a stress you would get? More or less? It is definitely more. එතකොට අර tolerate කරගන්න අමාරුයි. දරන්න බෑ එතකොට. සමහරට කැඩලා යන්නත් පුළුවන්. අපි දන්නේ ඒක. එයාලා කියන්නේ මෙන්න මේක දරන්න පුළුවන් columns ගන්න ගන්න කියලා. 30 columns. So as civil engineers, what they are doing, they take the total weight, entire weight of the system and decide how many columns they have to place to tolerate that total weight. So it's something like this. Right, number B. I will come to number B now. So there's a question again. Since it says stress for each column, don't we have to multiply the stress by n? No, the total stress, the stress that is tolerated by one single column is this value. One single column is this value. What I did there, I know the total weight is this. What is the total weight? It is 5.4 10 to the power 8. I divided by n to take into a one column. So now I know for a one column, this much of force must be applied. To find the stress, I just multiplied by the area. Did you get the point? All right, okay. Number B. Determine the Young's modulus of steel from the curve given in figure number 1. So how to find the Young's modulus from the curve? How to find the Young's modulus from the curve? It's also given, we discussed that one under the theory. How to find the Young's modulus from the curve? From the gradient. From the gradient, we know it is proportional limit. Proportional limit, under the proportional limit, we can find it. This value, according to the graph, this value looks like 1.5. It is 1.5 10 to the power minus 3. Even this value become 3 neither. Yes, 3. At location A, it looks like 3. 3 10 to the power 8. So Young's modulus for the B part 1, Young's modulus equal the gradient of let's say OA. You better write like this. Young's modulus equal the gradient of OA. Gradient of OA. How to find the gradient? Equal this value divided by that. 3 10 to the power 8. It is multiplied by 3 10 to the power 8. 1.5 10 to the power minus 3. Here 2 10 to the power 11 Newton per meter square. It is the Young's modulus value. 2 10 to the power 11 Newton per meter square. Okay. Question number 2. Part B, number 2. If the height of the steel column is 4.995 meter, what was its original uncompressed height? Let's say uncompressed height is L. Uncompressed height is L. Let's say it is L. If you place certain weight, it is now dropped to 4. What is that value? 4.995 meter. This is the compressed amount. Let's say E. So when you place certain weight, what is that weight? We can calculate that value F divided by 30. If we calculate earlier, F divided by 30, when you place it, you get 4.99 M. So they ask you to find the L value, right? L value. So how to find it? We will find the strain first. How to find the strain? Two 10 to the power, for the 2 10 to the power 8, for 2 10 to the power 8, 2 10 to the power 8, what is the strain? For the material like this, I told you stress versus strain graph is a unique graph. For a copper, it is unique. For a, they mentioned this is steel. Based on the material like steel, they prepare the columns. So the steel, this is a unique graph. So when it is 2 10 to the power 8, what is the strain? Can you tell me the strain value here? When it is 2, what is the value? What is the value, Lamai? Yes, 1 10 to the power minus 3. It is 1. So I know the strain now. Look at how we get the answer based on the graph. It is 1 10 to the power minus 3. You can write there the strain when the stress is 2 10 to the power 8. The strain is 1 10 to the power minus 3. Can you write this? For the part B, part 2, please write the numbers, right? Otherwise, you feel difficult when it comes to find the answers. Please write there. When the stress is 2 10 to the power 8, the strain become 1 10 to the power minus 3. Therefore, extension divided by the original length equal extension divided by the original length equal what? The strain equal, instead of E, I put that L minus 4.995. L minus 4.995 is E divided by L. Strain we got 1 10 to the power minus 3. L divided by L, 49995 divided by L, 1 10 to the power minus 3, 1 minus 4.9995 divided by L. Take it to here. 4.995 divided by L, 1 minus 0.001, 0.998, 0.995 divided by L. L approximately we get 5 meter. It is 5 meter. When you simplify, you would get 5 meter. අපි මේක graph එකෙන් ගත්තේ 2 10 to the power minus 11 minus 8, sorry, 2 10 to the power 8 stress. What is the strain? We found it based on that graph. The strain must be maintained at 1 10 to the power minus 3. Anything to ask? Right. If you complete that, I will prepare to start number C, part C there. Shall I erase the board? Right. Finish. Okay. Right. If the columns have a circular cross section of radius 15 centimeter, the radius is 15 centimeter now. 15 centimeter means diameter is 30 centimeter. 30 centimeter for the part C. 30 centimeter. Mention above, does the number of columns calculated in A2 above would be less, same or more? Give reason for your answer. Right. So the number of columns depends on the area we selected. For example, the area of this would be 30 into 30. It's a square. Now it's a circular one. If this area, if the new area is less, do we need to think about the more number of columns or less amount of columns? For example, let's say the answer is 900, right? If you select 500 square centimeter column, what kind of a thing I should select? I should increase more columns there than 30. So I should decide whether the circular area is more or less than this 900. Actually, no need to calculate, Lamai. I can tell you exactly. If I place the square here, the square here, we realize the area is more than the circular area. So actually what we should do, we should increase more number of columns. Can you understand that? Is it clear? So look at the practical question is, can you understand we should increase the number of columns? Right, fine. Can you write the answer, Lamai? Can you write the answer? Just write under that. The area of cross section of a circular column, the area of cross section of a circular column is less than that of square column, is less than that of square column. Therefore, need more columns. Can you draw that one also? Then you realize that part. Right, finished. So Lamai, I will tell you a small thing. I have explained if you have two strings like this, let's say mg is applied. I told you the extension are the same for the two strings, two wires or the two cables. The extension are the same for the two wires. Remember that. Different forces would apply F1 and F2. Instead of placing this, if you place two strings with series like this, series, string A, B, C, and place this mg weight, what is the special thing here? What is the special thing? When it is parallel, the extension are the same. When it is series, what is the same? Different extension, but same tension, same force. Force is same. Remember that. You will getting a new question for this idea as a mock paper. Remember that I haven't touched even in MCQs there are, but in essay question you don't feel this kind of question. Remember the same force but different extension. Right, okay. So with that, we will move to another question. Question number 32. Question number 32 in our tutorial. 31 we did, 32. Figure shows the stress versus strain curve if the Young's modulus is vastly different. Example, rubber and steel in the parallel rubber and steel in the parallel one would with extension be different? No, there is no difference because the finally the same object is moving down, or yeah, moving down, so same extension is maintained. Remember that for the parallel situation. For the different material, anyway, the different material also we have the same extension. For the question number 32, we can come to the answer. Question number 32, it's again graph P versus, looks like the strain versus stress. Figure shows a stress versus strain curve obtained for a material for all possible stress values. Identify the point A, B on the curve. A, B. A, B. What is A? What is A here? Elastic, the A is the proportional limit, B is elastic limit. Right. Calculate the Young's modulus of the material. What is the energy stored per unit volume when the strain in the material is 2 10 to the power minus 3. I would put the values here. It is given as 2 10 to the power minus 3. Here it is 4 10 to the power minus 4 10 to the power 7 Newton per meter square. So Young's modulus can be calculated. Young's modulus can be calculated from the graph, from the gradient. This value divided by that 4 10 to the power 7 divided by 2 10 to the power minus 3. So 2 10 to the power 10 Newton per meter squared is the Young's modulus. And also they've highlighted what is the energy stored per unit volume. From where we get the energy per unit volume? From where we get the energy per unit volume? I told you this. From the stress versus strain graph. Which one? From where we get that? From the graph, which area? Yes, we would get that from the area. This is the area we should consider under the strain of 2 10 to the power minus 3. The energy per unit volume, the store energy store energy store per unit volume equal area under stress versus strain graph. These things are for you to understand. Area under stress versus strain graph. Area equal half this one divided by multiplied by that 2 10 to the power minus 3 multiplied by 4 10 to the power 7. 2 cancel 4 10 to the power 4 joule per cubic meter. Remember the units joule per cubic meter because it must be per unit volume. Right. Let me to come to question number 3 now. Have you come to this point? Shall I erase the board? Shall I erase now? No, you can't take that as a breaking point. It is not given. Figure shows the stress versus strain graph for the obtained for a material for all possible stress values. Yes, all possible stress values. They have mentioned about that. Yes, you are correct. You are correct. I'm sorry about that. Thanks for highlighting that part. Actually, point B must be the breaking point. It should be breaking point. Why I'm telling like that? According to the question, I even missed that. The figure shows the stress strain curve obtained for a material for all possible stress values. All the stress values were given here. There are no more stress values. So that means the maximum thing is there. So that these represent not the elastic limit. It is the breaking point. You are correct. Can you please correct it? It is the breaking point. Reason එක තමයි ඒක කියනවා ඕ හැම stress values ම මේකේ පෙන්නනවලු. ඒකෝට ඉතින් හැම එකම පෙන්නනවා නම් අපිට අනිත් ඒවාත් පෙන්නනවා නම් අපිට පුළුවන් වෙන්නේ B කියන එක කියන්න elastic limit එක කියලා. ඒක මේකේ කියන්න බෑ. මේක මොන material එකක් වගේද? It looks like what kind of material? What kind of material is this? Looks like what? Brittle material. Yes, it looks like brittle material. Right. Shall I come to the question now? Question number 3. Question number 3. The vertical cross section of a cylindrical pillar consisting of a solid cylinder A and a hollow cylinder B, each of height 2.5 meter and made of the above mentioned material is shown in the figure. I just draw this first. .5 meter, each one 2.5 meter. This is solid one, but this is hollow cylinder. This is taken as A, this is taken as B. Radius of A is 10 centimeter. This is 10 centimeter. And external and internal radius 10 centimeter and 7 centimeter respectively. This is 7 centimeter and this is 10 centimeter. The diagram is not drawn to the scale. What is the compression of the pillar when the load of 110 to the power 5 Newton is supported by it? Now you place a load, a certain load, which is equal to 110 to the power 5 Newton. 110 to the power 5 Newton. It is applied on this block and also this block and that block, both blocks. It's applied on both blocks. Let us find the compression on block A and block B separately. Let's say E1, the compression on A. E2, the compression on B. Compression on EA, E1, compression on B is E2. F over A equal Young's modulus E over L. So subject E, F L divided by AY. F 10 to the power 5, L it is 2.5 divided by the cross section 5 R squared. R equal 10 centimeter, 10 to the power minus 2 squared. 5 R squared is the cross section area into the Young's modulus 2 10 to the power 10 because we found it. E1 we could obtain from here. E1 we could obtain from here. Anyone calculate that value? E1 we can get it from there. 4 10 to the power minus 4 meter. Since it takes time, I will write the values. 4 10 to the power minus 4 meter. This is the E1. Similarly, we can calculate for the B, for the E2. E2 equal F. What is the value of F? What's the value of F here? If you consider this cross section, this is the cross section, Lamai. It's a hollow one. Cross section. What is the force applied on this cylinder? What is the force applied on this cylinder? The top one 10 to the power 5. Bottom one? Same, exactly same. Good. It is same. As I told you, the series concept. If they tell you, if they highlighted this as certain weight, then I should consider this weight plus that weight. Both weight I should consider, right? They are not telling you a certain weight on that. The Kenul is asking that, I guess. Even I told you, if the value of the if the weight of A is given only, you have to consider. Since they haven't provided the weight, I should consider only 10 to the power 5. 10 to the power 5. Length is 2.5. I'm using the same equation. A, cross section area. How to find the cross section area? Check whether you are clear with this. 5R square 10 to the power 2. Sorry, 10 to the power minus 2 squared minus 7 10 to the power minus 2 squared. Why I multiply it like this? Why I multiply? I take the difference of those two. Because I should consider the cross section area. Internally, we have a hollow part, cavity part. We have to remove it. It's a hollow cylinder, not the solid cylinder. 10 to the power minus 2 squared minus 7 10 to the power 2 minus 2 squared into what? The Young's modulus 2 10 to the power 10. Can you understand how I arrive the answer for the area? Is it clear for you all? 10 to the power minus 2 squared. We are getting the big area. I should remove the hollow part. 7 10 to the power minus 2 squared. Are you clear with that? Every one of you? Every one of you clear with that, right? Clear ne? Hari. Okay. Right. What is the maximum load? No, what is the compression? So E2, I would write the value E2. E2 probably you would get an answer like 7.8 10 to the power minus 4. So when you do that question as homework, please try to simplify that. So the total compression is E1 plus E2. No, they want us to find the individual one. No? What is the compression of pillar? No, they want us to find the total. So take the addition. 11.8 10 to the power minus 4 meter. It is the answer. 11.8 10 to the power minus 4 meter. Right, finish, done. Shall I erase the board? Right. What is the maximum load that can be supported by the pillar without breaking it? Without breaking it. Right. Now we have two cylinders. What do you think? Do I need to consider the solid cylinder or the hollow cylinder when the braking would consider? The braking part would consider which cylinder I should consider, either A or B. The hollow one. Exactly. Are you clear with that one? Hollow one. I should consider the hollow one first because the area is limited there. The area is only area is less than the area of A. So it get more stress than A. Right? If the braking would occur, definitely it is through B because the area is now less than A. What is the braking stress? What is the braking stress here? For the material for the material like this, what is the braking stress? It is given in the graph. What is the value? 6 10 to the power 10. It is given as that. It is given as that it is 6 10 to the power 7 Newton per meter square. It is the braking stress. If you know the braking stress, let's say 6 10 to the power 7. This is for the part B. Braking stress equal 6 10 to the power 7 Newton per meter square. Please write that. 6 or the sigma equal then F divided by A. 6 10 to the power 7 equal force. I should find force. It is the required force. Area 5 10 10 to the power minus 2 squared minus 7 10 to the power minus 2 square root of this. Sorry, square of that. So with that we can find the force. What kind of a force it should be then? 9.6 10 to the power 5 Newton. 9.6 10 to the power 5 Newton. If you apply this kind of force, definitely start to break. For to occur the braking part, F can even go more than that value for A. But since this is a combination of those two, definitely I should consider this one first. Can you understand that question? Is clear for you all? Is it clear for you all? No problem, right? Slamai, was it clear? If they are asked to calculate the force at which A brake, the same stress, for the same stress, the area would be different. The area would be different there. Area is 5 10 to the power minus 2 square. I should consider that area. Same stress. මෙයා කැඩෙන්නෙත් එකම ස්ට්‍රෙස් එකට. මෙයා කැඩෙන්නෙත් එකම ස්ට්‍රෙස් එකට. එකම දේ ෆෝර්ස් එක අනුව වෙනස් වෙනවා. දැන් මේ එකම ෆෝර්ස් එකනේ අපි ඇප්ලයි කරන්නේ. හැබැයි මෙයා ඒක දරා ගන්න විදිහත් මෙයා ඒක දරා ගන්න විදිහත් වෙනස්. මෙයාට ඒක දරා ගන්න අමාරුයි. මොකද මෙයාගේ ඒරියා එක අඩුයි. මෙයාට ඒක දරා ගන්න පුළුවන් මෙයාගේ ඒරියා එක වැඩි. ඒක තමයි ස්ට්‍රෙස් කියන එක ඉම්පෝටන්ට් බව. Stress is so important concept than the force, right? අර හොඳට මතක තියාගන්න දරා ගන්නවා කියන එක tolerate කර ගන්නවා කියන එක අමාරුයි මෙයාට. Because area is less. Here it can tolerate. The area is large. Right. Question number 30. Question number 30 in your tutorial. Question number 30. Can you write something for the previous question? When the force is increased, when the force is increasing, when the force is increasing, when the force is increased, when the force is increased, the cylinder, the hollow cylinder within bracket B start to break first. Start to break first. As the area is less than the area of A, as its area is less than that of A, as its area is less than that of A. Less than that of A. Right. For the question number 30. Question number 30. We will come to the question number 30. Young's modulus E of a material in the form of a wire is given by F over A delta L over L. Here all the symbols have their usual meaning. Identify the terms F over A delta L over L in the expression. Here the material of the form of the wire. Actually, if you just write the stress and strain, so that is not enough, Lamai. It is tensile stress, tensile strain. So when you stretch something, I told you it is tensile. When you compress it, I told you another thing. What is that? What is that? When you compress it, there's a separate name for that. When you stretch it, it is, yes, compressive thing. Compressive stress, compressive strain. When you stretch, it is tensile stress, tensile strain. Here it is tensile stress, tensile strain. Figure 1 is a characteristic curve showing the elastic behavior of a material. Identify the point X and Y marked on the curve. It is actually X is proportional limit, Y is, what is that? Y is what? Breaking point? It is elastic limit. They are not telling you that part, the previous part. All the possible values are not considered here. Just X and Y is asking. X is proportional limit, Y is elastic limit. Two uniform nylon strings of length 10 centimeter and 2L, which is 20 centimeter, of similar area of cross section are separately fastened to a rigid oval shape frame as shown in the figure number 2A. Right. Both strings, use marks that first question number 30. We can mark it oval shape. It is 2L, it is 2L, and it is L. L is 10 centimeter. Right. The length of that is 2L and length of that is L. Think about the badminton racket. both string and they are having the same cross section, both string just stretched with a negligible tension, no tension at all when it is like this. The string lay perpendicular to each other. That means the both are in the perpendicular situation. The strings are perpendicular to each other and just touch each other. Now a force is applied to a point of contact of the string and perpendicular to the plane of containing string as shown in the figure number 2A, 2B. You should understand it clearly, Lamai. Let's say this is one string and the other string. I apply certain force perpendicular to the plane. So can you imagine this situation now? You should imagine the situation. For the longer one, I can consider for the longer one, it is 2L. This 2L. Now it is like this. It is like this. For the short one, it is L. It is now like this. You should understand practically. If X is the depression of the point of contact of the string due to the application of forces, here it is X. Here it is X. This is L by 2. This is L. Are you clear with that? The total length is 2L. So half of that L. Total length is L. Half of that L by 2. Compress. They have same extension. Actually, they don't have the same extension. The depression is X. It does not tell you the same extension. Same extension කියලා කියන්න බෑ. දැන් කොහොමද මම මේක explain කරන්නේ? You have a string. You press it. I will take a rubber strip. Let's say you have a rubber strip like this. There's another rubber strip in perpendicular to that. Let's imagine one thing. You press it at the middle. I think you can't see that, ne? Even I can't. I can't because I don't have 3 hands. I can't show you. One, you can understand. This one, think about that. The same thing is the other side. So imagine this location and this location. It is X, not the extension. Okay. It's dropped by X amounts. Right, fine. If X is the depression of the point, okay, fine. Write down the expression for the increase in length of the two strings in terms of X and L. Right? For 2L. For the part C, part 1. For 2L, I can write, let's say the extension is the length is L1 here. The length is L2 here. L1 equal L squared plus X squared root of that. Write down the expression for the increase in length. Increase in length, I should multiply it by 2 to get the total length L1 2 minus 2L. Check whether you got the point. For 2L, for the string, the increase in length equal 2L squared plus X squared minus 2L. Can you hear my voice, Lamai? The outside there's a raining. right? 2L squared plus X squared minus 2L. Okay, ne? It is the increase amount, increase in length. For L string, increase in length equal L2, 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 what is the value? X squared plus or L by 2 squared plus X squared, root of that multiplied by 2, because L square, L by 2 squared plus S squared is that value. We have two things, minus L. That is the increase amount, increase length. There is nothing to understand. It is Pythagoras theorem. You have L here, you have X here. They asked you to find this one, L squared plus X squared, root of that. We have another section in the other side. The total length is this, 2L squared plus X squared, root of that. Initially it was 2L. So what is the increase amount? This is the increase amount. Did you get it? Did you get it? Right, okay. Right. Derive expression for the tension of the two strings in terms of E, A, L and X, where E is the Young's modulus of the material of the nylon string. So now we can get the tension. Let's say the tension here as T1, the tension there as T2. Hooke's law we can apply for the number 2. Hooke's law, F over A equal Y E over L, F equal A Y E over L. For 2L string, T1 equal A Y E. Instead of E, I should substitute this value. Extension is this. 2, I can take 2 out. Ne? We will take 2 out. L squared plus X squared, root of that, minus L. Divide by L. For L string, T2 equal A Y 2 L by 2 squared plus X squared, root of that, minus L. Divide by L. Sorry, L, not L. It is by 2L. This must be L. This must be 2L. Ne? This is L. I can cancel 2 to cancel. We can say for the 2L string or the longer string or the shorter string. AY L squared plus X squared minus L divided by L. AY 2 into L squared divided by 2 X squared minus L divided by L. Right, finish, clear? Right, fine. If X equal 0.5 centimeter, substitute the values given in L and X and hence show that the tension of shorter string is higher than that of the longer string. Right. Let's find it from T1. Let's find it for the T1. T1 equal cross section A, Young's modulus Y, L squared. It is actually 10 centimeter. 10 centimeter, 10 squared plus X, that is 0.5. 0.5 0.5 squared, 0.5 squared minus L, that is 10 centimeter, multiplied by 10 to the power minus 2 to convert into meters, divided by here L, which is 10 centimeter, 10 to the power minus 2. Actually, it is cancelled. T1 equal AY. In the question, they ask you to take this value as what? 10.0125 divided by 10. Divided by 10. They ask you to take that value. They ask you to take that value. When x equal 0.5, L equal 10 centimeter, take x squared plus L squared as 10.0.125. Just divide by 10. Similarly, we can calculate T2 AY from here into 2 L by 2, L by 4, that means L squared by 4. Either of these two. No, it's not that. I should take the difference of those two. Because instead of this one, they asked to take 10.0125. T1 equal then AY into 0.0125 divided by 10. T1 equal AY into 0.00125. 0.0125, let's say Newton. Similarly, T2 we can calculate from here, cross section y into 2. Either of this one, they ask us to take 5.025. Uh, 5.025. I should divide by 2, ne? It's wrong. There's a small correction. No. Look at here. Look at here. Here, if I take 2 out, I should take L by 2. Can you understand that simplification is wrong? Increased length is 2 L squared. L squared divided by 2 squared. L divided by 2 squared plus x squared minus L. So I should take L by 2 if I take 2 out. Can you understand that simplification, Lamai? Can you understand that simplification? Right? If I take 2 out, no, not T1, because that is 2L. The initial length is 2L. No need to change it there. But in here, it is not 2L, it is L. Shorter length, the shorter string, it is L, not 2L. When I take 2 out, I should make it L by 2, then only it become L. L by 2 මෙතන වෙන්න ඕනේ. මම ඉස්සෙල්ලා පොඩ්ඩක් වැරද්දක් කරලා තිබ්බා. L by 2 වෙන්න ඕනේ. Right. AY2, they asked you to take L squared divided by 4, L divided by 4 squared plus x squared. You can take 5.025 minus 10 divided by 2, it is 5 divided by 10. So T2 equal AY 2 into 0.25 into 2 means 0.050 divided by 10, which is equal to AY into 0.005 Newton. We don't have enough room to write there. That is the issue. AY 0.050 divided by 10 means AY 0.005 Newton. Can you see the board, Lamai? Can you see the answer for the last one? Can see, right? Sorry about that, no space. AY 0.005. So the T2, the tension on the shorter string is this value. The longer one is AY this value. AY into that value. Which one is large? Which one is large now? Its speed T1 we calculated. T1 we calculated 0.00125 AY. T2 we calculated 0.0050 AY. Which one is large? It looks like T2 is greater than T1. Tension on the shorter string is more than the tension there. T2 is larger than the T1. T2 is larger than T1. Can you write there, when it comes to this point, can you write the tension in the shorter string, tension in the shorter string is greater than the that of longer string, longer one. Longer one. Right. The next question. Explain qualitatively how the two strings behave as the applied force to the point of contact of the string is increased. If I consider stress versus strain graph for this, the same could be obtained. You can take this as X and this as Y. This as X and this as Y. This as X and this as Y. Explain qualitatively how two tension behave as the applied force to the point of contact of the string is increased. That means if you apply more force, what happened to the tension values? That is our question. We realize actually the stress is equal to the force divided by area. The force is greater than the force on the longer string. It's very important point. Please try to take this point. If you apply the same force on the string, the both string, what happened? The tension on the shorter string is greater than that of the longer one. Then the shorter string would reach the proportional limit first than the longer one. Is it clear? Because same area for the both nylon strings, same area. We realize the tension is greater for the shorter nylon string than the longer one. The tension is increased, that means the stress is increased rapidly than the other one, than the longer one. So the shorter string reached the proportional limit soon when compared with the longer string. Are you clear with this? Are you clear with this? Are you clear with this, Lamai? So try to pick it because it's very important section. ඔය nylon string එකට අමින මේ graph එක ඉතින් nylon නම් common right? nylon නම් ආයෙ වෙනස් වෙන්නේ නැහැ. ඔය graph එකම තමයි එන්නේ. එතකොට අපි clear කරගත් එක point එකක් තමයි short string එකේ tension එක ඉක්මනට වැඩි වෙනවා. long string එකට වඩා. ඒකනේ අපි තේරුම් ගත්තේ දැන්. එතකොට මම කියන්න point එක දැන් මේකෙදි එකම cross section එක නිසා මේකේ proportional limit එකට ඉක්මනට reach වෙනවා shorter string එක. ඕක මම force versus if I plot it for the for to clear it more, force versus extension graph, if I plot it for the force versus extension graph, I can draw something like this. For longer string, for the shorter string, for the shorter string, if I plot it for the longer string, I should draw it. What happened to the gradient? The gradient of this f over a equal y e over l. F equal a y divided by l into e. When the length is increased, what happened to the gradient? What happened to the gradient when the length is increased? What happened to the gradient when the length is increased? Decreases. So I should consider a gradient which is less than this value. Right? So let's say we have a tension which shows the elastic limit, proportional limit. Same tension for the both wires, same proportional limit for the both wires, but with different extension. I can explain based on the two graphs. මේකනුත් මට පුළුවන් මේකනුත් පුළුවන්. මම මේකෙදි explain කරද්දි මට ඔයාලට කියන්න පුළුවන් මේක ඉක්මනට වැඩි වෙනවා short string එකේ. ඒක නිසා එයා මේ location එකට ඉක්මනට reach වෙනවා අනිත් එක්කෙනාට relatively. මේක ගැන explain කරොත් මට කියන්න පුළුවන් මේකෙදි ඔයාලට තේරෙනවා මේ පොඩි extension එකකට ටක් ගාලා මෙයා pick කරනවා elastic limit එකට proportional limit එකට මෙයාට relatively. මෙයා තව ටිකක් යන්න ඕනේ longer string එක. This is longer string. Longer string. Proportional limit එකට pick කරන්න නම්. Not clear? Fine, right. Can you draw these two graphs? Can you draw that? It's a very important question. You can do more questions based on this idea when it comes to MCQs. You can try all the MCQs. Yes, this is the past paper question actually. This is, if I'm not mistaken, this is 2012. I couldn't exactly remember 2012. I think it is 2012. Okay, can you write this? As the applied force is increased, as the applied force is increased, the tension in the shorter string, will reach the proportional limit, which will reach the proportional limit, will reach the proportional limit earlier than the longer string, than the longer string. So after that, most of the force will act on the longer string, So once it reached the proportional limit, it is not further increased, further increase the tension, because tension is remain the same, but it is applied only for the longer string, and it will provide the extension for the longer string. You can understand when it comes to this point, longer string has the extension at here, shorter string has the same extension, but it goes further for the longer string, it has more extension. Right. The next question, draw a rough sketch for the tension versus extension curve for the ball string on the same graph and label them. I did that, ne? I did that. Right. Can you turn to page number 6, question number 90? Is there any other question? Suggest a method which enable, right, there's another part, sorry. Suggest a method which enable both strings to reach the condition depicted by the point X shown in the one simultaneously. That means they want us to take both sections simultaneously the proportional limit. What we should do? We can do this one. We can shift this longer string. Look at here, I am doing this. I can do this based on this. To shift it, I should provide initial tension on the longer string. Then only I can do that. මේ එකම වෙලාවේ proportional limit එකට ගන්න නම් මම මේ string එක පොඩ්ඩක් shift කරන්න ඕනේ. ඒක කරන්න නම් initial tension එකක් දෙන්න ඕනේ. Initial tension එකක් දීලා අපි පටන් ගන්නවා. එතකොට පුළුවන් මෙයාව shift කරන්න මෙතෙන්ට. එතකොට යන්නේ අර graph එකේ එක තැනකදී යා coincide වෙනවා. ඒක proportional limit එක. Clearද? ඒක කරන්න නම් මොකද වෙන්න ඕනේ? Initially you have to provide force on that. Tension must be provided at the beginning. Tension must be provided at the beginning. Is it clear for you all? No, not the horizontally. You can do the same way. You can provide the vertically downward tension. You can do the same thing separately for the longer string. So like what you apply the vertical downward force, you can do it for the separate force. You can start the separate force at the beginning, or else you can, since it's an oval shape one, at the beginning they told you there is no tension. You can provide the tension. You can provide the tension at the beginning and apply this force, downward force. Then you can reach this one. Eh? Understood? Then badminton racket එකේදී ඔයාලා tension එකක් දෙන්න පුළුවන් නේ එක string එකකට. Tension එක මෙයාට initially දීලා පටන් ගන්නවා. එක string එකකට badminton racket එකේ ඔයාලට මේ ගොඩක් තියෙනවා මේක මේ දෙකයි පෙන්නලා තියෙන්නේ. Just for an example, badminton racket is not exactly this, but the same idea is there. Is it clear? Small gadget attached to the racket. Racket is the same concept. Yes, I think yes. I'm not exactly sure with that. That's another thing. There is a small gadget attached to the racket. Is the same concept. I think that is the concept, but I don't know exactly that is the reason. I think that is the reason because they want to provide much tension at the beginning to provide both have the same reach the same proportional limit. The question asks you suggest a method which enable both strings to reach the condition depicted by the point x shown in the figure 1 simultaneously. Simultaneously, if both strings come to this location, that means I should initially provide the tension on the longer string. Then only I can reach that simultaneously. Can you write that? Initially apply suitable fixed tension to the longer string. Initially apply suitable fixed tension to the longer string. So now this the string is not go along this path. Instead of that, it go along this path. So at a certain location, it could cross the exact point with the shorter string. Initially, we are given the value. දැන් අපි මේ අඳින්නේ 0 ඉඳලා දෙන potential එකක් ගැන හිතලා නැහැ. අපි ඉස්සෙල්ලා දීලා ඉන්නවා යාර. ඒක initially value එකක් තියෙනවා.